I previously showed you our first eWasm prototype on a Cosmos SDK chain, built on the foundations of CosmWasm. This has changed. We are dropping CosmWasm and building our own eWasm engine from scratch with WasmEdge as the WebAssembly engine. So I'm introducing WasmX, a framework for multiple collaborating execution engines on the same chain. And today you will see a demonstration of eWasm, a first execution engine to be implemented under WasmX. We might provide our own flavor of CosmWasm later that has a more streamlined API for developers, so they don't need to worry about matching the call replies to the correct call. If you know CosmWasm, you will know what I'm talking about. But right now, WasmEdge allows us to do some very interesting things in terms of increasing the efficiency of contract interoperability, something that no other chain has. And we are able to load multiple contracts at once and maintain tight communication between them. If you recall our pipeline visual language project from 4 or 5 years ago, we still believe that contract interoperability is key. So what you will see today is a demonstration of our new eWasm on WasmEdge engine. We start from a Solidity contract in Remix that is compiled to Wasm and deployed on our Mythos testnet chain. And we are using our own Remix plugin to do this and interact with the contract. I am in Remix here and I have already loaded our Mythos plugin. Right now we don't have any contracts compiled, but we see 3 tabs: Compile, Deploy, and DApp. Let's compile a simple storage contract by just doing a Command S keyboard shortcut. And now the plugin shows us the contract bytecode, ABI, and WebAssembly text for the contract. What has happened is the EVM bytecode has been transpiled to WebAssembly in the background. And now we can just go to the deployment tab and our storage WasM bytecode is already loaded. And we can just upload it to the chain. You can upload the contract once and then reuse the contract for multiple instances of contracts that have different constructor arguments, or better said, instantiation arguments. So the result of uploading is that we have been given a code ID for this WasM bytecode. And now we just put on a contract label and we give an argument for the constructor of the contract. And then we instantiate this contract. So we have instantiated this number variable with 6 as an argument of the constructor. And as you noticed, we are using Kepler because we are using a Cosmos SDK compatible API, and Kepler is connected to the Mythos network. After the transaction is done, we also receive a contract address that is automatically filled in our DApp. This DApp is created from the ABI of the storage contract. So we can easily interact with the contract. So we can get the value and read what is already stored on chain, which is 6, the value we provided in the constructor, and we can change this value to, for example, 10. The transaction is done, so now if we do a get, we see the value has been changed to 10. So today you have seen that you can develop Solidity or Yule contracts and you can deploy the eWasm on a Cosmos chain. The rest of the features will be shown in future demos. The newly found flexibility for our WebAssembly engine will allow us to bring life to a truly flexible system. A system where core development is truly decentralized on merit instead of personal relations and money. Because true innovation that benefits humanity at large is driven only by ideals.